Hi, I'd like to explain a little bit of the pneumatic system on Pop Rock. So over here we can see the air cylinder on Pop Rock, the whole ram assembly. These are all the custom pneumatic components on Pop Rock, and from the outside they look like a fairly standard air cylinder. But you can see on the bottom there's free ports, and once we look at the section view we can see there's a little more to it. So there's basically free air chambers. There's the pressure, the buffer tank, where high pressure air is stored before it's sent to the cylinder, and then we have the valve pressure chamber, and then we have the ram. So in basic operation, this chamber fills up through the port on the bottom with high pressure air. Once this chamber is up to pressure, we actuate the valve by exhausting the pressure in this chamber, allowing the valve to move down and kind of pop open because of the surface ratio difference when it is closed, meaning the pressure in here doesn't need to be very high to hold back all this pressure. So that pops open and then sends the ram flying up. Once it's extended and we want to reset the ram, we can repressurize this chamber and exhaust the air from the cylinder, allowing the valve to retract and allowing this to repressurize. So I've detailed all these components in the schematic, specifically in this square box. This is all the custom components of Pop Rock. The rest of the components are off the shelf and used for the rated purpose. So quickly, high pressure liquid CO2 is stored in this container and then regulated by a paintball regulator that prevents the liquid CO2 from moving past. Then we have the main solenoid that will be normally closed but open once it's in the arena, just to prevent the custom stuff from being charged outside the arena, kind of like an arm disarm, and allows me to do it remotely. Then we have our drain and overpressure valve to allow us to vent the robot after the match, and in case there's some sort of regulator failure, it will drain anything over 200 psi. Then we have over here, this is our stuff to supply the valve with air and control it, and then we have our exhaust solenoid, external parts. So quickly, air goes out this tank, regulated down to 200 psi, goes and fills the buffer tank. While it's doing that, it goes down, gets regulated, and sent into the valve section and pressurizes the valve. And that's regulated to a much lower pressure, probably about 80 psi, probably less than that. Then to fire the ram, we switch the solenoid and exhaust the air from it, and we have this quick exhaust valve just to help it flow faster. This pulls out the air, allowing the valve to open, sending this ram up by moving the air through the valve into the ram, so it moves up at a high speed. Then to reset, we switch this valve again and send the air and exhaust the air in the cylinder out through this exhaust solenoid. When we're depressurizing, just to make sure that this section doesn't vent before the buffer tank does, we do have a check valve that prevents this from fully depressurizing. But since there's a nominal amount of air and it's all contained within that cylinder, it's a minimal risk. And all the working pressure, once this is opened, there's no chance that this could fire. Cool. Thanks for listening.